All right, Integrated Math 3 students. We are going to be finishing up our lessons for this unit today. And the topic that we're about to get into is one of the essential topics. So of all the content that we've covered so far, this will be considered one of the most important things. Okay, on DeltaMath, you have 15 questions that go with it. So this is the most problems that you have for any of the problem sets on DeltaMath. So I'll be sure to give plenty of examples with this video, but I would also recommend that you go back to my YouTube. You don't have to stick with play pause it after you watch this. Go to my YouTube and you can rewatch and follow along if you need some more step-by-step help when I work problems on DeltaMath towards the end of this. We're going to do 2 examples by hand first. Okay, so we're going to be taking this function here and we're going to make a sketch of it. So this isn't graphing. This isn't I'm taking the points, the x and y values, and just plotting them on a graph. We are just going to make a simple sketch. So let me go ahead and display this for you. Here is the function. So go ahead and get this copied down in your notes. Heard that when I pause the video, there's like a pop-up. So I'm gonna have you pause the video. I might see if I can't fix that and pause it myself, but that's what I've heard from students, is that there's always some like a pop-up in the way. So just write this real quick. Okay, so let's go ahead and also draw yourself, I'm gonna use this here, draw yourself a XY axis on your paper. So here's my y-axis, my x-axis. Okay, so we're going to keep adding to that gradually. And you'll want to use these steps that I'm about to write down to help you with the DeltaMath and, of course, just the future problems that you work when you're trying to sketch graphs or create functions in factored form here. So let's write the first step. First step is find and plot X-Intercepts. Okay, so that's going to be what we do first. So down below here, let's go ahead and write x equals. So you had to do this in the Integrated Math 2 review, except it was for quadratics. We got them into factored form, and then we found the x values that made it equal to 0. I said X-Intercepts, I'm so sorry. Hopefully you're not using pen. I want to actually rephrase that. Honestly, it means the same thing what I'm going to write, but I'd rather call them zeros in this context. So the zeros, that's what we want to find. So I'm going to go ahead and ask the question. I'm going to pause this video. Here's the function. What are the zeros? Okay. All right, so the zeros that you should have come up with, very simple. If you remember from the iMath 2 review, to get the 0 of this, we're just taking it, x minus 3, you don't have to write this, is equal to 0. Well, that's going to be x equals 3. So that's one of them. And sort of the trick, we'll call it, is you're just sort of flipping the sign. So 3 is one of them, 2 is one of them. Then what's this last one? Okay, well, it looks like it's going to be 1. Now, the question here is, what does this square, how does that affect things? Well, if I were to rewrite this, it would be x minus 1, x plus 2, and x minus 3, right? Because that's what that square means. It means write it twice. Well, do I write the 1 twice? Well, no, you don't do that. But there is a term for this that we looked at in the last video, in our last lesson. This is, and I'm going to underline it, that is a multiplicity. Okay. Put on air to that. Multiplicity. So we need to actually, because that's important for our graph, okay? We're going to write that. I'm going to move my numbers over. I thought I had enough space, but I don't. So because that x minus 1 is happening twice, we have 1 is one of our real zeros, yes. But it's going to be a multiplicity. We write it like this, MULT, multiplicity, we put 2, okay? Then we put the rest of them, so -2 and 3, which I think I had +2, so that was a mistake. I'm sure some of y'all were trying to correct me through the screen. So there are our zeros, okay? So we'll talk about how multiplicity affects this, and I think that that's the most complex part of this, is understanding these multiplicities. But go ahead, plot these zeros, and we only care about these zeros. So I'm only going to do 1, 2, 3. 3, I'm going to put a point there. 1 right here, and then 1, -2. That's all I care about. So I'm going to plot all of those, and we're done. Now again, this is going to be a simple sketch, so we're only putting critical values on here, okay? That's the first critical values that we're going with, but we need to sketch a little bit more. The second part that we want is the Y-intercept. So we want to find and plot Y-intercept. Okay, so I'm gonna ask an open response question in here because I want you guys thinking through this. Here's our function here, x minus 1 squared plus, or times x plus 2 times x minus 3. How would I go about finding the Y-intercept? Okay, so I want to hear your ideas for this, and we'll see if you get it correct. So go ahead and type up how you would find the Y-intercept of that function. All right, so how do we find the Y-intercept? Well, there's actually several ways to do it, okay? And if you replied with, graphing to find it, you're not wrong. If you replied with putting the function out of factored form, putting it in standard form, because we're in factored form right now, you're not wrong, because that would be the constant value. But the most efficient way for the current situation, and hopefully maybe somebody put this when I look back at them, is you just want to find the value. So we know it's going to be either here, don't plot this yet, it's going to be up here or down here, but we know that the X-intercept will be 0, or that X value, not X-intercept, the X value will be 0 no matter where it is. It's always 0. So that means that how we phrase this is when X equals 0, right? That is true for the Y-intercept. So our method for this will be plug in 0 for X. We're going to end up doing. So I'm going to erase what I put here, and one of these points we're going to use. Go ahead and give this a try. So I know that it's going to be f of 0 equals, we have 0 minus 1 squared times 0 plus 2 times 0 minus 3. So what happens is the zeros just go away and we're left with these values. Okay, so let's go ahead and solve this. Make sure that you use parentheses if you're using a calculator for this, and when you're squaring the -1, remember anything squared is positive. So this is going to be 1 times 2 times 3, -3. So our Y-intercept is -6, okay? 6 is the Y-intercept. So we're going to place this Y-intercept, -6, it's going to be down here. So we're just going to call this -6 for the Y value, okay? And now we don't actually care about this top point. So go ahead and make that adjustment on your graph. Now we have these, sorry if that bothers y'all. Now we have a lot of our critical points figured out, okay? Next step, we need to determine and graph in behavior. That is the plan. Determine and graph in behavior. Okay, well, remember from our lesson over in behavior, and hopefully you've been able to do those problems on DeltaMath where you have x goes to infinity, y goes to infinity, all of that stuff, and hopefully that made sense because it's going to be super important for this to help us out. first off, let's talk about concavity, which I'm going to rewrite as, or I'm going to add the note, this is the right side in behavior. That's really the goal. So this is telling me how the right side of my graph will look. So I'm either going to draw an arrow. Let me show my example here. I'm either going to draw an arrow going up, or I'm going to draw an arrow going down. So this is going to help us figure out what's happening on the right side of the graph. Let's go down and let's figure out how we're supposed to determine this. That's the goal right now. So if you remember from the in behavior video from an equation or a function, we were always using, so this, don't write this, but we had ax squared plus bx plus c. And we were looking at the a value to tell us what the concavity was. So we know that if it was a positive a value, we were going up on that right side. If it was negative, we were going down. That was our distinguishing factor there. All right. But we noticed that we are not in this form. Check it out. We are in factored form. Okay. Okay. Sorry, I had to turn off one of my sound gates. I think I've probably been choppy this whole time, so I apologize. It should be clear the rest of this video. So let's go ahead. We're not in standard form. We are in factored form. So let's write down the general factored form. Because this is going to be important to help us with this. So we have, here's our format. F of x equals a times x minus r1 times x minus r2 ... how many ever factors there are. So these are the factors, r1, r2, those are the roots or the x-intercepts, right? So that's what we found right here, 1, -2, and 3. We got those from these and we changed their signs. And then we look at our function. What is the a value up here? That's the question. So what is our function's a value? I'm going to pause and you're going to answer that question. What is the function's a value? Hopefully you said it was 1. And more specifically, hopefully you said positive. Okay, so in this situation, we are going up because a is positive. So what that means, here we go ahead and on your notes, draw with me a line going up from this 3, okay? And that's the correct in behavior on that side. Now, we need to figure out what's happening over here. Is it going up or is it going down? Okay? So to determine that, we need to figure out the degree, okay? And specifically, whether or not that degree is, let me put a little star there, a little star here, if that degree is even or odd degree, which is the highest power. So highest power, what is the highest power of this function? So we go back up to it. Well, it's not in standard form, so it's not very easy to tell this. But from our last notes, we wrote down this rule. Degree is equal to the number of zeros. Okay, so how many zeros do we have? Go back up, we look at it. 1, 2, 3. Okay, so does that mean the degree here is 3? Well, remember with multiplicity means we count it twice. So we're going to add that. Multiplicity gets added together. So we have a degree of 4. So degree equals 4. Okay, so now we've determined that the degree is 4. So now we want to know, is this even? Which would mean same direction. Or is it odd? Which is opposite directions. Well, it's very obviously even, so we know that this is what we're looking for. So it's going to go in the same direction. So this is going to go up. Okay, so that's the in behavior. Everything else that's happening in this graph, we're going to get in the next step. Okay, so let's go ahead and do that. So step 4 is complete the graph. That's really the step, completing the graph. Okay. And remember, multiplicity, which just touches the graph. And don't forget the Y-intercept. So we have to go through every single one of these critical points. And for a lot of students, this is one of the most challenging parts, is remembering all these. So we know we have a multiplicity at 1. So let's talk about how this would look. Anywhere that it's just a straight 0, we're going to just go straight through the graph. So I have a 0 at -2, and here I start. I'm going straight down, okay? So what's the next critical point I want to go through? Well, that would be that Y-intercept. It's right here, -6. That is the next point. So I go down and through there, okay? I'll just go out a little bit. Then what's the next point? Well, the 1 right here, okay? And what do I know about that 1? Well, it is a multiplicity from right here. It's a multiplicity, so that means it's just going to touch the graph. It's not going to go all the way through, but it's just going to touch and bounce back the direction it came. So I'm going to go, I don't want to use blue. We're going to go up, bounce off, and that brings us back down the other way, okay? Then the next point is this 3. Now, our graph has to curve back to that point, so we're going to go down and then curve back up, okay? It's not just going to go down and make a sharp curve back or turn back up. It's got to curve back up, okay? So this is a rough sketch of our function, and that's exactly what I'm expecting of you, okay? What is the purpose of doing this? Well, what we're trying to practice is you understanding how to plot these X-intercepts from a function and finding Y-intercepts and using in behavior, all those skills that we've learned, okay? The main factor, or the main point of this, is to be able to plot the zeros from this function, okay? That's the real and true goal of this, okay? Let's do one more example. We'll speed it up a little bit. So here's the next one. Let's go ahead and write this. We're going to do, this is example 2, f of x equals x squared times 2x minus 12 times x plus 2 times x minus 2. So for this, go ahead and draw yourself a xy axis. And we want to start, step 1, we want X-intercepts, okay? I'm going to go ahead and tell you that there are 4, and I would like you to try to list those out for me. Okay, so I'm going to pause it. All right, so I think right away everybody knows that -2, and let me just write it out here, -2 and 2 are going to be zeros. Okay, that's pretty straightforward. You're changing the sign. You may have struggled with this. Let me tell you what it's not. It is not 12. 12 is not correct. Okay, we're not just flipping this from the it's the 2x minus 12. We don't just flip the 12. This 2 plays a role here. So this is what I would do. 0 equals 2x minus 12. Well, what do I get when I solve that? Well, add 12 to both sides and then divide by 2, you get 6. That's actually the 0 that you want. And you can always solve for a 0 like this. All right. Now the fourth one is a little bit trickier, and it comes from this right here. Okay. What would be the 0 for that? Well, what do I plug in? I had a lot of students that were saying, oh, it's 1 or it's -1. Okay, well, that doesn't make sense. X minus 1 is 1. That would be the factor. So that's not what we're seeing here. Okay, what value do, if we get rid of everything else, if I did this, all right, if I was just looking at that term, what would I plug in there to get 0? Well, hopefully, maybe you already got this, but hopefully you would say, I plug in a 0 in there. If I plug a 0 into x squared, it's always 0. And that's true, okay? So that's actually going to be the last root. Now, the square still comes into play. What did the square mean on the last problem? It meant, look at the blue here, it meant multiplicity, or red here with the square. Anytime I see a square, that's telling me multiplicity, okay? I'm writing it twice. That's what that means. So we're going to put multiplicity 2. And there's all of our zeros. So we're going to go ahead and plot those. So I'm going to put some tick marks. 1, 2, 3, 4, 5, 6. So 6, 2, 0. So I'm going to go ahead and plot these as well. 2, 6. And then we have -2. Got it? Okay. So let's go ahead and look at part 2. We want the y-intercept. Remember, that means plug in 0. Okay, so plugging in 0, that gives us f of 0 equals 0 squared times 2 times 0 minus 12 times 0 plus 2 times 0 minus 2. Write that right? Yeah, okay. So then we simplify it. 0 squared is 0. Then we get -12, 2, and -2. What do I get when I multiply all that? Well, hopefully you don't even need a calculator, because look, there's a 0 up front. 0 times all of this is equal to 0. That's our y-intercept. That should already make sense, actually. Look back at your graph that you drew over here, and I forgot the 0. Look at that. That's the X-intercept, or that's the y-intercept right there. That's where it's crossing the y-axis, and that was our definition that you probably wrote down a moment ago when I asked about that. But yeah, that's going to be our y-intercept. So we're done with our y-intercept at this point. Okay, so I don't really need to add anything. Part 3, in behavior. Okay, concavity is a positive or negative. So positive or negative. Well, remember from what we wrote earlier, going back down to this, here's the general form. We're looking at the a term on here, okay, to figure out if it's positive or negative. Last time the a term was a 1. There was a. What do we have in this problem? So it looks like that x squared is up there, but we don't care about a variable. It has to be a number that we're looking at. So once again, this 1 that's just sitting up here is actually going to be a. So what that means is, in this case, it is positive. Okay? So go to your graph. Positive means we're going up. Let me actually put that back down on the bottom. We go up on the right side. Write that as well. Up on the right side. So from 6 going up. There we go. So we got that. Now, What is happening on the left side? Is it same direction or is it opposite directions? Well, what is our degree? Well, the degree of this function, remember we have to count the zeros. How many zeros are there? 1, 2, 3, 4, but this one counts twice. So our degree is actually 5. So is that even or odd? Well, it's clearly an odd degree. So that means opposite. So that means I'm going to go the opposite direction. Okay. Now, the step 4 was to complete the graph. Remember the y-intercept and remember multiplicities. Our multiplicity is at 0. So I'm going to add my 0 there, so 0. So watch how this works. The graph starts, it goes through -2, up, and then it's going to go here. And what happens at 0, we have the multiplicity. Remember, it has to just sort of bounce off. It's touching it and then it bounces off. So this is going to go down and back up, okay? Then we'll curve back down to the next point, which is 2. We have to go straight through. Look at the 2 here. It is not a multiplicity, so it just cuts straight through. And then we curve back up to the last point, which obviously is going to go straight through because it's a 6, and look at the graph. So this is correct right here, okay? Let's go ahead and look at a DeltaMath problem. Okay, so let's talk about like the efficient way for you to work a DeltaMath problem, okay? So here's what it looks like. It's saying we need correct signs. We're going to graph a sketch of correct signs, X-intercepts and Y-intercepts. That's why we went through those steps, just to make sure that you were very successful in this, but all of those are really good steps as well. So with this, let's start with step 1, which is find the X-intercepts, always, okay? So for this, the X-intercept, we are here, we know it's -3, and you have -6, and then 3x minus 3. Okay, so what is that? Well, I need to solve for that. 3x minus 3 equals 0, so that's going to be 3x equals 3 because I add the 3, then it's x equals 1. So that's going to be my last one. What you'll notice here is that there's no multiplicity. We don't have any square values, okay? I'll probably do one more example after this, and I'll make sure that one has a multiplicity so we can see that, okay? But let's look at this one. There's our X-intercepts. We have those. What I want you to do as you're working a question, okay, always draw your own sketch first, because it's going to make it a lot easier to go from your sketch to what you need to sketch instead of tracking it in your head. So like I said, we want to plot these. So let's go to 2, 3, 4, 5, 6. So -6, put a 0, -3, put a 0, and then we just want 1. There's the 0. Okay. So we've got those plotted. Now, number 2, we want y-intercept. So I'm going to take this function here, and put 0 in, which is 0 plus 3, 0 plus 6, and 3 times 0 minus 3. If you want to try to speed this up a little bit, which I'm not suggesting to anybody, but if you really have a good grasp on it, you could just go ahead and write them like this if you wanted to, because we know that those zeros are just going to get rid of the term. So 3 times 6 times -3, well, that is 9 times 6, or 3 times 3 is -9, 3 times -3 is -9, times 6, so what's 9 times 6? Well, that should be, I'm doing my mental math. If you need to use a calculator, you can. I'm not perfect, so even your old math teacher needs it sometimes. -54 is what we're looking at. So we're going to plot that down here. Remember, the sign is so important. If a lot of students are making mistakes that I'm seeing on the y-intercept, so you got to make sure you have this right, or it's going to just woefully confuse you, okay? So -54 is down there. All right, what's the end behavior? What's happening on the right? Well, what is our lead coefficient? Over here, is it positive or negative? Well, in front of this, right in front, is a 1, so it's positive, so we know the right side's going up. You always start from your furthest right point, so I'm going to use this 1 here. We're going up, okay? What happens on the left? same or is it opposite? That's what we want to know. Well, what's the degree? The degree is 1, 2. There's 3 zeros, so 3. Okay? No multiplicities this time, so we don't have to worry about that. Just put 3. Okay, no multiplicities. So the left side will be, it's odd, so that means opposite. So the left side is opposite. So this, from this -6, we're going to go down. All right. Now, we're going to complete the graph. Remember the y-intercept and remember multiplicities. We don't have any multiplicities. So all of these, you're just going straight through and curving. So through -6, curve down, all the way through this, curve back down, we get 1. Okay, that's a really ugly graph, but again, this is just a rough sketch, and hopefully it'll do better over here. So let me show you how this is going to work on DeltaMath, and this has been super frustrating for some students. The key on this is patience. Steady hand helps, obviously. I don't think that doing this on a phone is going to be feasible. You can let me know if you're trying to use a phone, but you'll probably need a laptop, and I absolutely recommend using a mouse, but you can use a touchpad. Okay, that's not out of the question. So let's look at how this works. Watch this. I can really graph anything I want on here. Look at that. That's not a function. That would count that wrong immediately. Okay, but I can draw anything. I can draw a straight line. I can draw a parabola, somewhat of a parabola. Okay, as good as you can. I can draw a nice cubic, something like that. Okay, so we're just going to try to draw the sketch that we have over here. The most important thing that the computer's looking for is in behavior correct X-intercepts and correct Y-intercepts. Also multiplicity. So this question doesn't have multiplicity, but if it did, you'd want to make sure that you kept that in mind. Okay, so let me show you how to start. I'm always starting on the left, and I know I'm going to start at the bottom, and I'm going up through -6. Then I look at I'm looking over, peeking at my sketch, looking constantly at it. The next point is -3, so I'm going to curve back down -3. Where's the next point? Oh, it's my y-intercept, so I'm going to go through -54, which on my scale here is here. And again, you can be close. I know that some of y'all are looking at this and you're like, that didn't hit -54. It's fine, okay? The computer wants you to get close, but you don't need to be too far away. Next, I'm going back up to 1. Okay? Now let's say that I'm not happy with this and I want to try again. If you submit this, it may be right, but it may not be. So those that are sort of perfectionists, you may want to resketch this, which is what I'm going to do. To resketch, I just click and it erases it. So we start over. -6, -3, -54, up through 1. There's my graph. So we check our answer. Let's see, hopefully. Okay, I got it right. So what it does is it's going to show you what the actual graph would have been, and then you can see how yours was. Mine was pretty darn close. I think I nailed it. Okay, but that's going to be the skill, and again, this is going to be frustrating for some. Okay, but it is important skills that we're learning here and practicing. So just be patient with it and be persistent. That's what I keep saying to people. Let's do one more example. Not that one. No. Let's do this one. That one seems good. Let me do a new page. Here we go. So, X-intercepts. Okay. Graph. Okay. 1. X-intercepts. So, X-intercepts are going to be, we look here, well, it's 4, right? But when we see the power, that means multiplicity. So I'm going to go ahead and put mult 2. There won't be a multiplicity 3, by the way. I had some students in class ask that. The next one, what is this? Well, if I solve that, 2x minus 2 equals 0, we're going to get x equals +1. So I know it's a 1. Then what's this last one? Well, that's -2. Okay, so we have our X-intercepts. Go ahead on your paper. You would want to go ahead and start making a sketch to follow. And these sketches can be super ugly. They don't have to be pretty at all. But I know that I'm going to have -2. I'm going to have 1, 2, 3, 4. I have a 1, and then I have a 4. So I'm going to mark all those. All right, that's all I need to do. All right, next, we want the y-intercept. That's plugging in 0. into the function. So 0 minus 4 squared, 0 minus 2, or 2 times 0. Sorry. And then 0 plus 2. Again, you could just go ahead and write it like this if you wanted. There we go. So this is going to be 16 times negative 2 times 2. So that's going to be, this will be negative 32. Negative 32 times 2 is negative 64. So that's our y-intercept. So I know going up here, I'm going to plot just any point anywhere. Negative 64 is the y-intercept. All right, so in behavior, 3, we want the right and we want the left. All right, on the right side, what are we seeing? Well, looking at the function, what's the lead term up here? Well, it's positive, it's a 1. So we go, it's positive, so we go up on the right side. So on my sketch, I'm going to go from 4 up, like so. What's happening on the left? Well, what's the power? What's the degree? We look at it. What is our degree? We count the x-intercepts. 1, 2, 3, 4. So 4 is the degree. So we know that that's even. We'll say 3 equals 4. That means it's the same. Even means the same. So we go over here, we know it's going up. Okay? So we need to draw this. I always start on the left. So at negative 2, I'm going straight through it. There's no bounce off of it. So it's just negative 2. So I go straight down. Where am I going to? Well, I go through my y-intercept. That is the next critical point. So through that, then I go up to the 1. I'm going through it because it's not a multiplicity. Then 4 is a multiplicity, so I'm going to go back down, and it just curves up. Okay. Then my sketch, I'm using that to draw mine over here. So I know I'm starting up here from the top left, going down. So I'll start here, go through negative 2, and you can see I missed. That's okay. I just click and start over. So through negative 2, missed again. Good enough. Down to negative 64, up to positive 1, curve back down, and bounce off 4. Okay? Try to make sure that it's not like a straight zag like that. It does not like that. Make sure that you have a little bit of the curvature to that. Okay? Let's see if I got it right. I got it. Okay. There's the graph, and mine is kind of close. You don't have to worry too much about how far these go. You don't want it to be dead flat. It needs a little bit of a curvature to it, but you can see sort of a comparison about mine. This is where I'm going to stop the video. This was a very long lesson, but this topic is very challenging with the DeltaMath and then just understanding it in general. But with 15 questions of practice, you should have the hang of it by the end. Okay. I would highly recommend just rewatching the steps of this video as you are, working this. Have this video side by side. It's going to be on my YouTube, so don't use play pause it after this point to rewatch this. Go to my YouTube channel, Woods Math. I'll put a link in the in this video, and get it done there. Okay, if you need side by side. Okay. Outside of that, if you need me to work more examples, send me a message. I don't know how much time I'm going to have over the next few days to send out more examples like this, but this is just going to take persistence and trying for your work. Obviously, every question is going to show the solutions, so you can look back and see maybe where you made your mistake, but you need to make sure you're writing your work. Okay, we'll go ahead and stop the video here.